The next lesson in Topic 6 is 6.3, Properties of Parallelograms. The definition of a parallelogram is a quadrilateral with two pairs of parallel sides. That makes it different from a kite or a trapezoid. The opposite angles are congruent in a parallelogram, and the opposite sides are congruent. Consecutive angles, like same side interior, still add up to 180. And another big difference is both diagonals bisect each other. So over on the right, we're just going to kind of sketch what we see down below. We'll have two parallel segments, and then we're going to have another pair of parallel segments that connect them. Ooh, that's not really the greatest version of that, but we'll make it work. I'm going to write an arrow on the top and bottom to show that those two edges are parallel, and a double arrow on left and right. That would be the definition of a parallelogram. Given parallelogram ABCD over on the right, the definition allows us to write a single arrow on top and bottom and a double arrow on left and right. Or you could reverse that and do a single arrow left and right, double arrow top and bottom. What we know about angles, there's a lot that we can mark. We know that angle A would be congruent to or equal to angle C. And angle B is congruent to or equal to angle D. Those are opposite angles. Consecutive angles have a different definition. For example, the measure of angle A plus the measure of angle D, those are same side interior angles. They add up to 180. So do the measure of angle A and the measure of angle B. That's an 8 right there. Angles B and C add up to 180. And C and D. Wow, that's a lot of information just about angles. So on our picture, let's go ahead and mark angle A with a single arc and C with a single arc. And then we'll mark angle D with a double arc and B with a double arc. Opposite angles are congruent. Consecutive angles would add up to 180. Over on the right, what do we know about side lengths and diagonals? Let's start with side lengths. We know that opposite side lengths are congruent, which would mean AB is equal to CD. Now on the picture, it has a single arrow on it, but we can also mark it with a dash. Same rule would apply the other way. AD is equal to BC. Now this one would require a double dash, meaning those two sides are also equal. But then it talks about diagonals. So we have to draw those in. Let's use a dashed edge to connect A to C and to connect B to D. Now they intersect at a point in the middle, and I'm going to call that point X. Diagonals bisect each other. So that means AX is equal to CX. And DX is equal to BX. Now, and that's what we know about the side lengths and diagonals in a parallelogram. What we have to also kind of recognize is that AC doesn't necessarily equal DB. That won't be true unless it's a different type of quadrilateral. Let's take a look at example 1 down below. Given parallelogram WXYZ, what is YZ? If I'm using two letters, that means we want that side length from Y to Z. Now, by definition, WX is equal to YZ if this is a parallelogram. Simple enough, that makes YZ equal to 3.27. If you know one side length, the opposite side length, always the same. Now that second example down below, measure of angle W plus the measure of angle Z. These two are angle measures on the inside. Angle W is on the bottom and angle Z is also on the bottom, but notice they're not opposite from each other. Z is going to get a double arc. Because they're consecutive, meaning in order, by definition, they will always add up to 180. All right, flip it over. Quadrilateral PQRS is a parallelogram. And if all four sides are marked, we're asked to find the value of x. We know that QR is equal to PS, and we know that QP is equal to RS. We just need to take one pair and set them equal to each other. So let's go with QR and PS. If we set 7x minus 3 equal to 2x plus 12, we're just going to incorporate some algebra. Let's move both of the x's to the same side. And I'm going to move the negative 3 over to the right. I'm going to do 2 steps in one here. The 3's cancel on the left-hand side. 7x minus 2x would leave me with 5x. On the right-hand side, the 2x's cancel. 12 plus 3 is 15. To get x by itself, I kind of ran out of space here. I'm going to simply divide both sides by 5. 15 divided by 5 is 3. There we go. There's our answer for the first question. Had we set the left side equal to the right side, we would have gotten the same result for x. But then it says for part B, what is the length of each side in PQRS? So now we need to take 3 and plug it back in. I'm just going to start at the top and go for QR. 7 times 3 minus 3 would be 21 minus 3, which is 18. That means PS should also equal 18, but let's just double check that we did our work correctly. 2 times 3 plus 12, there we go. 6 plus 12 is also 18. That's a great way to show that we have the right value for x in part A. All right, let's go to the left side and the right side. Find QP. This one should be pretty easy. 4 times 3. I'm going to write it in the correct order here. 4 times 3. QP should equal 12. And RS, if we just verify by plugging in that 3, 5 times 3 but minus 3 is 15 minus 3, which is also 12. Incorporating a little bit of algebra with these parallelograms. Let's try an application question. The 600-meter fence around City Park forms a parallelogram. The fence along Chaco Road is twice as long as the fence along Grover Lane. What is the length of the fence along Jones Road? All right, let's look at the picture. We know that there's 600 meters of fencing total, so all four sides have to add up to 600. That would be perimeter. And that equals 600. Now it says that the fence along Chaco Road is twice as long as the fence along Grover Lane. So it looks like Chaco Road is longer. On our picture then, if we're going to try to label, I would say that the length of Grover Lane is X, and then the length for Chaco Road is twice as long. If that's true, then Jones Road is also X, and Village Drive would be twice as long. Now, if the perimeter of all four sides has to be 600, we're going to add the four side lengths together. So I'm going to add Jones Road plus Village Drive plus Grover Lane plus Chaco Road, and set that equal to my perimeter of fencing, which is 600. On that left-hand side, all we have are x's. I've got 1x plus 2x plus 1x plus 2x for a total of 6x. To get x by itself, we'll just divide both sides by 6. X equals 100. Now we're asked to find the length of Jones Road, and that's what x is. X is the length of Jones Road. What that means then is that Jones Road is 100, but then our label is meters, since the entire perimeter was measured in meters in the directions. Example 3. Given parallelogram ABCD, what is the measure of angle B? Well, if we look at the picture, angle D is 114. Notice angle B is opposite. And by definition, opposite angles are congruent. The measure of angle B is also 114 degrees. Well, then we're asked to find the measure of angles A and C. Well, now looking at the picture, angle A would be supplementary or add up to 180 with angle D because they're same side interior. So the measure of angle A plus 114 would equal 180. Well, to get A by itself, let's just move 114 to the other side. That makes the measure of angle A equal to 66 degrees. And again, recognizing that opposite angles are congruent, angle C is the same thing. So parallelograms have a lot of congruency in them. It's kind of nice. All right, let's try one more example at the bottom and we'll call it good for this video. It says the green shape in the fabric design is a parallelogram. And I know it's really hard to see, so my apologies that this didn't print in color. So just arrow over and call that the green shape. I tried to darken in the boundary for you so that you could tell what was happening in that picture. All right, at any rate, it says the green shape in the fabric design is a parallelogram. The measure of angle 2 is 3 times the measure of angle 1. What are the measure for all the marked angles 1, 2, and 3 in that parallelogram? So like the city park question up above, we're going to have to take a look at how we can represent the angles now in this picture. It says the measure of angle 2 is 3 times the measure of angle 1. If you look at the picture, notice angle 2 is bigger than angle 1. That means angle 1 is just going to be kind of our start value, x, but then angle 2, because it's bigger, it's 3 times bigger, we'll call that 3x. What are the measures of all the angles that are marked? So 1, 2, and 3. Well, remember, by definition for a parallelogram, consecutive angles are 180. So we could say that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. If angle 1 is x and angle 2 is 3x, now it's just algebra. Combine your like terms on the left-hand side, that gives you 4x is equal to 180. If we divide both sides by 4, x equals 45 degrees. Now that's the measure of angle 1. So down below I'm just going to write measure of angle 1 equals 45 degrees. And the measure of angle 2 is 3 times the measure of angle 1. So if I take 45 times 3, that's 135 degrees. That's the measure of angle 2 and the measure of angle 3, because they are opposite angles. And that's working with parallelograms. I'm going to have you take the quiz and then we'll finish our notes the next time we are in class.